Now let's look a little bit deeper into how we do really implement cache coherence. Let's go back to this picture of Snoop-based cache coherence protocol implementation. We have the cache, we have the CPU, we have the bus. The cache lines are governed by a state transition diagram, as I said. There are some commonly used cache states, and you have seen quite a few of them, but let's go through them once again. Let's begin with the bottom here, invalid. That means that a particular cache line does not have a valid copy. That's the easy thing. The contents of the cache line is just not valid. Next one from bottom, S for shared, means that the cache has a clean copy, which also means that the memory is clean, so anyone can grab the copy from memory as well. And also others may have a copy. There may be one or more cache copies in the system. Owner state or owned state, O, is a similar kind of state, except that it signifies that this cache line has once been modified so that the memory is dirty, or the copy is dirty, so that when it has to be discarded, we have to write it back to memory to update the memory. It allows, the system allows one cache line to be in the owner state, and the other ones may be in the shared state. And then we've seen the modified state, M, which means that my dirty copy is the only cached copy. Memory is not clean, so if someone else wants to read this data, it has to be copied from the cache in the modified state. If someone else wants to write it, you have to copy it from, or you have to discard it from the one who has it in the modified state and move it to the one which wants to update it, and so on. The E state is a way to slightly optimize the protocol. Whenever you have a read miss, most likely is that you will never share it with anyone else. Most data is actually only accessed by one thread only. So if you bring it first to the E state, exclusive state, similar to shared, but you know that this is the only cached copy, then it's easy to go to the modified state from the exclusive state without sort of notifying anyone else, since you already know that this is the only cached copy. The hardware you need to do this is to make sure that you guarantee that when you make a read miss that this is the only copy that exists. Some common coherence alternatives are MSI, a three-state protocol, MOSI, which is the protocol you have seen earlier on, MOESI, and also some processors implement MESI, which is same thing as MSI, but with this exclusive state included. So remember what happens in a cache coherent memory system. Let's say we have these three threads that we have talked about earlier on. Thread 1, 2, and 3. There is a copy of A in each cache, and then thread 2 stores to this cache line, which means that invalidation messages will have to be sent to thread 1 and thread 3's caches, and eventually when thread 1 wants to read the data again, you have to do a cache-to-cache transfer from thread 2. We're going to go deeper into how this is implemented. So let's assume we have the cache line in state shared. This is exactly the situation before the invalidation. The cache line is in state shared in all three caches. Okay? State shared. One thread is then issuing a store instruction that leads to a CPU write. Since we're so the issuing processor will issue a CPU write, and since we're in the shared state, we don't have to read the data, we just need to invalidate it. So it has to also to issue a bus invalidation message on the bus. Okay? And then locally, you go to state modified. So here we're in the state shared. We do the store, bus invalidation on the bus. When you see that bus invalidation in the snooping mechanism here, you go to the modified state in the local cache. Okay? Let's see what happens on the other CPUs. So the cache line is in state shared. Okay? So what happens is that we will see the bus invalidation message on the bus. We'll have to go to the invalid state, invalidate the cache line. But that's basically all we need to do. So we see the bus invalidation, snoops it, and go from shared to invalid.